Today from the Ed I have another calculator here. This is a German-made calculator by Ludwig Spitz and Company, I believe is how it's pronounced. And it's a Unitas model calculator. And as you can see, it's really quite an early machine. It uses sliders for entering the numbers rather than, say, a keyboard. It has two registers, and a register, you can just run this register by itself, or with this register via this little tie-together bar. I'll have to explore that yet. You can do addition, subtraction, and of course by moving the carriage back and forth very manually, it looks like, you can do subtraction or division and multiplication. What's nice about this guy is I actually have some history on it. I bought it from the Pikes Peak Trolley Museum. I'll put in the description below a link for that if you ever want to visit that museum. It's really quite nice. They turn over their exhibits from time to time, and I think it's a Monroe Model F that's now being displayed where this guy had been. The original owner and user of this machine was the New York Ontario Western Railroad in Middleton, New Jersey. So it was in the general office building of the New York Ontario Western Railroad in Middleton, New Jersey. So it's kind of nice to know the early original history of this guy. How long, of course, it was in that railroad, and what it was doing after that before it wound up at the Pikes Peak Trolley Museum is a little uncertain. But it's nice to know that its earliest days and its most recent history. And it looks to be in really nice shape, other than just usual dirt and dried out oil and everything. I've tried to move a few things here, and everything's very stiff and doesn't want to hardly move at all. So it's a classic case of just open this guy up, probably clean and lubricate, and I'll bet that this guy will probably work just fine. Okay, so researching my nifty calculator here, I've learned quite a bit about it. It's actually a much more involved story than I would have thought. I just thought at first when I bought this calculator it was an interesting early machine with sliders on it. And it turns out to be quite a bit older machine than I thought, and its design is even still older than I'd realized. This machine, it looks like it was built probably around 1910 to 1913. And looking at the design, though, the design goes back almost 100 years before that. So basically, in effect, I have nearly a 200-year-old design technology here. The machine itself is physically 100 years old or so, but the design is closer to 200 years old. And the design goes back to about 1821, when an inventor in France, Charles Xavier Thomas of Colmar, France, he started developing this calculator, the basic design of it. And by about the 1850s, he was starting to make them commercially. But this particular design sometimes will be referred to as a Thomas-style calculator, or Thomas design calculator. It also can be referred to as a arithmometer. Arithmometer seemed to be a very common term right up until the early 1900s. Even the Burroughs calculator or adding machine company initially was called the American Arithmometer Company. So arithmometer was kind of a common term for calculators until it kind of fell out of favor in the early 1900s. So basically it's a design that's nearly 100 years old, and then Ludwig Spitz and Company is formed about 1906 or something like that. And so you could basically say this Unitas calculator is basically in effect kind of a clone or follow-on of the original Thomas style arithmometer, with a number of improvements. And what you'll find is there's a number of German companies, British companies, and of course French companies making these machines up until the early 19-teens, when they started falling out of favor. And then just looking at the ads and a nice photo from the Smithsonian Institution of a much later Unitas, by 1915, Ludwig Spitz and Company, they've pretty much developed this thing about as far as they'll take it. They've added a a keyboard. Basically, the keyboard works the slider mechanism in effect to actuate the selector drum system of the old Thomas design. They motorized it and so forth. But at that point, it's kind of a frozen design, and it doesn't appear to have really had a whole lot added on to it up into the 1930s, when it looks like the production of the machine ends. The next question is why did the New York Ontario Railroad buy this particular calculator? And it looks like quite early on they're advertising in American trade magazines. So I've found ads in Engineering Review, an insurance magazine, and so forth, dating to as early as about 1907. And you see various articles and ads for the very earliest of the Unitas style machines with the extra carriage and so forth. It's still in the classic wooden box in these ads, kind of very much like Charles Thomas's calculator clear back in the mid 1800s would have been in. And then there are several other manufacturers also. You can see their ads for British calculators or French calculators. And then if you look at there was a book, I have the link in the DVD of this video, called Modern Instruments and Methods of Calculation. A lot of the machines are basically available at the time, and it gives you some great insight as to the technology. There's of course the Thomas step drum technology. There's the newer technologies with the pinwheel machines, which I'm surprised actually to find out that, according to this book, they've been around for about 20 years themselves. And then there's also the new kind of upstart-ish, although there's been going for a few decades themselves, of Burroughs and Torrington and Felt. And then there's a number of nice examples, especially the Thomas machine. They aren't specifically for the Unitas calculator. There are several other German and British calculators that use the step drum that he does review in this article. And it's really quite a good article, so if you have the time, I definitely recommend looking it up. It goes into a lot of the nice design theory and trade-offs between the different designs. So it gives you kind of a feel for what was available for this railroad company to have bought, and why they would have done so. Okay, so for my initial exploration of this guy, in order to move the carriage around, you have to flip this guy up. You kind of it looks like you have to grab it from the side here, and you lift, and you can slide it around. And I think I slid it around once, and it doesn't want to move this time. I don't know if I have to adjust it on the right spot here. Might be. Okay, so I don't know. I think what I'll do is I'll disengage this extra arm here and put it in its little parking space, and see if I can just move this one carriage by itself. Okay, can't do that one. This one does move. Oh, so reluctantly. Okay, it's just everything needs to be lubricated so badly. Maybe I didn't slide this around. I thought I did, but I guess maybe I hadn't. What's interesting is the calculator itself, the actual mechanical guts, appears to be just this section here. This little kind of wedge platform is just a stand. It's hollow underneath. There's actually nothing in there. So it looks like, as far as I can gauge, the actual working guts is this kind of a parallelogram section here. And all this below is just a stand to have it present the controls to the operator at a nice convenient angle. And it looks like there's some little knobs here that you turn to get the little pie shape or moon shape, half circle, what do you want to call it, out of the way, that holds the plate on where you get it to the flat. And I believe this cover will simply come off. Yes. Wow, everything's really substantially made, and I think just looking at it, it looks like this is brass. So I was wondering if this was cast iron or brass. I think this guy is, because it looked like it was kind of gold over here too. So I'm thinking this thing might be made out of brass, not cast iron. I guess I should get a magnet and find out. Very, very substantially built. And then I can see in there the Lisbon's gears, drums. There's a view of one of them, as you can kind of see. You can see this this gear. It's basically it's a kind of a long spur gear, and the teeth are cut at various different lengths. And then another gear, I presume, is going to be slid. In fact, I think I can see it right here. It's probably this gear here. Is slid up and down on this square shaft. Let's see if that works. Okay. Oh, so stiff. So if I get up to the number 1 here, if I was to be able to rotate this guy, in fact I might be able to rotate it. Yeah, looks like it does rotate. Okay, so it's going to engage this first gear here. And it did seem to move. It looks like there's several carries going on. Interesting. Oh, quite a few carries going on. Okay. Just happened to go as last in the machine when I got it. So these, this is really kind of a clever little device. There's lots of little sliding mechanisms here. You got your number wheel for your selector that's being turned somehow. Probably maybe it's a crank. I'm not sure at the moment. Maybe it's might be a rack and pinion gear in here. And then you have this gear that's sliding on a square shaft. It's being slid by this knob. And then this gear turns this guy. Let's see here. Okay, and then that goes further into the mechanism and then does various stuff. Okay. All right. So I'm getting kind of a quick view of this. It's interesting because this is basically the earliest method for entering, information into the rest of the mechanism. So this is a very early way of doing things, and it's so simple and straightforward that really not a whole lot can go wrong. You just have to lubricate and clean everything. So I think that's probably the thing to do, would be to do that. I might next figure out how to take the carriage off, because ultimately I'll probably have to do that to lubricate. I can't even hardly move this carriage back and forth. I think what I'll do first is see if I can just lubricate this guy and see if I can get it to move a little bit better. It looks like we have a couple pivot points here, or slide points here. Let's see if that might encourage some motion here. Oh, wow. A little bit of oil can go a long ways. Okay, so that does that. And what's interesting is these things are just a big slab of metal, it looks like, with all the wheels and everything on it. And I think it's going to be a lot like a Monroe calculator, in which case I think it looks like this side is machined. Oops. This side's it's machined down, and this acts as a stop. I suspect this guy is a screw, and I can undo this screw, and then I think this thing will probably just slide right out. Make sure I'm not in a spot where I'm going to damage somebody. There we go. Yes. It's right in a long screw. Okay, one screw, a shoulder screw. And I think this guy will simply slide out now. Looks like it. There we go. So, quite the mechanism. Okay, as the upper carriage removed, you can see just how beautiful this is made. It's all brass. Nice big gears. Looks like little pieces of sheet metal, spring steel, that act as little stop dogs, or what do you want to call them, that would keep the wheels from over spinning, kind of hold them in place until they're turned again. It's all brass. This whole carrier plate, all these other pieces are brass, there's a gauge. And it's amazing, you know, stuff like this didn't get scrapped during various World War drives for scrap metal. You know, there's so much brass in this thing that it's nice that it survived, you know, those potential, you know, loss. Then you can see various gears in here that obviously would have turned those guys. It looks like, I think, these can be shifted up or down, and it'll basically engage to one side or the other of these gears and cause the wheels to turn one way or the other, and I think that's how they reverse them. I'm guessing this is maybe part of the carry mechanism. So I guess the next thing is to get the lower carriage out. Kind of expected it's largely identical to the first one. Looks like there might be a few other little mechanisms in here, that, or at least they're more visible. I think part of what I'm seeing is the clearing mechanism for clearing the wheels. Okay, so everybody's been lubricated here and wiped down of the excess oil, and it's cleaned quite a bit of material off. All these guys slide pretty nice. They seem to slide easier one direction than the other, and that's just probably the nature of the mechanism. 9 seems to be a little bit more to get to latch. And just generally, you know, oiling and working and exercising the mechanism. So far, that's pretty good. Alright, quite a bit of progress in lubricating. It's just, you look for every little point that seems to be a sliding or rotation or what have you. Give it the minimal amount of drop. Definitely playing around with this guy, I can definitely see why folks would prefer to go to keyboards rather than sliders. You can reshoot these very easily, so entry is kind of slow and a little bit fidgety. You have to be kind of methodical about putting it in. You can't just whack a key and move on really quickly. So let's see here. What am I at? 1, 2, 3, 4. I guess I'm at 5, 6, 7, 8. So it's interesting how it cascades along. And everyone is moving amazingly well. I'm really just amazed how well this is moving. The other thing that's nice is that these canceling mechanisms now work correctly. Let's see here. It's just not as speedy. Okay. And then everything cascades kind of the other way. And then if I move this shift lever over, I believe they all go in a different sequence. And then this guy here has a kind of extra engagement here that can then causes, I believe, let's see if I can get that engaged here. I thought I had it understood once before. Let's see here. Okay, there we go. It latches underneath. Okay, there we go. So there's a little sheet metal hook here that gets get underneath that guy. Get that around. You push that in, and you get underneath this guy, and then that lever goes with the other lever. It gets out of its little engagement point, and will move the lever back and forth. And I believe that will cause the carriages to operate in backwards or forward. I'm not sure. I'll have to look at the label which way this is going. Considering how many mechanisms you have to actuate, the amount of hand crank forces, not all that unreasonable. Probably a little more lubrication and cleaning might help. But I'm kind of surprised how well it works. The next thing to do is there's a sliding mechanism that does the canceling mechanism. That looks like that definitely needs quite a bit of oil. It's a long slab of metal. There's a slide in amongst a bunch of other surfaces, so it looks like it's definitely something that's going to need a fair amount of attention here. Feeling a lot better. Well, the carriage, the main carriage, lubed up as best as I can. I think the next thing I want to do is probably put it back on the machine and is this guy back in place. I think that's the furthest over it will go. Let's see here. What do we get? Ooh, I get an overflow. Okay, so I'm in probably subtraction. Alright. 1, 2, 3, 4, 5, 6. Alright, so breathing some life into this guy here. So I'm going to see if I can put a bunch of ones into this guy. And then from there, I think I will test the carry mechanism here. Yep, that worked. So let's go with let's see here. Well, that's pretty good. Now the thing that's kind of awkward about this guy is you have to lift the carriage to clear the mechanism. And it's like, do you put your fingers underneath there? There's a whole lot of purchase here. The things that make you can get pinched. Or are you supposed to kind of push the carriage up with the lever and then do the cancel? Not sure. It's definitely, you know, I'm obviously biased towards the stuff I was introduced to first, which is a Monroe calculator, so this seems, you know, awkward. It does look like the rev counter is working. I believe that these don't have carries, so once I get to 9, it won't carry over to the next one. It'll just, yeah, it gets counts down with red numbers, and then it's back up to 1 again. Okay, so this secondary carriage seems to be as lubricated as I can get. I still got to clean the dials and everything, but see if I can get this guy back in without damaging anything in the process. It's another long, awkward rod. Seem to have jammed here. Well, after having put on the little smaller upper carriage, it kind of worked okay for a while, and then it started jamming, and now it's pretty jammed. So I'm taking this guy off and trying to figure out what's going on here, and I think it's this guy right here is jamming for some reason. I'm not sure why. You can definitely see that it's this guy here, I think, is causing the trouble. There. Lots of lubrication on the lower carry mechanisms. Still going to test that. Lots of lubricating on the upper carriage mechanisms. And you keep thinking that it's getting better, and then it hangs up again. So this is definitely got to be one of the more vexing devices so far. There's just so much to go wrong with this guy, and it's all in the carry mechanism. Just everything else seems to be pretty nice, but boy, that carry mechanism, if things aren't perfect, and it's just, yeah. Usually you can lift the carriage and you can kind of get past things, but then it just jams. I don't know. No amount of oil and thing seems to quite make these guys quite happy. it's a design that could definitely have used a little further refinement. But you know, they made these things they made about near the gauge 30 or 40,000 of these guys over 1906 or 8 when they first started. About 19, I believe it was 30 that they, was it 1930? Basically the company stopped making anything after that. It seems like the company was around until about 1940, according to some of the information I can divine, but it's, they might have been just rebuilding old machines and maybe making a few ones from old, you know, remaining stock that was sitting around or something like that. Sometimes you hear about these companies that kind of die very slowly on the vine, and that's kind of how they wind up going. Well, I'm really jammed this time in a big way. I can't get anybody to move. So anyhow, it's definitely early tech here having some troubles. Okay, so I've pushed in these little fingers up here. You now can't see, but you can see the little ratchet paw mechanisms here. And now as those fingers, which are of course now out of your field of view, come around and start pressing against these gears, which are also out of your field of view, they'll start rotating these little star-shaped parts that basically keep the wheels from spinning out of any sort of sequence, out of control. So they'll rotate. See here, at some point the paw is going to do its thing. Okay, so this paw is about ready to go over its tooth. Click. And we'll do it next, which unfortunately is out of the field of view. And this guy. And then, I don't know, is that in the field of view? I guess it is. Okay, so there's that. My efforts at trying to demonstrate this and get enough light and actually be able to understand and see what's going on is quite frustrating. I got this kind of angled as best I can over the most troublesome guy, although the next troublesome guy is next door. Here's the second most troublesome, and here's the most troublesome guy. And as I rotate here, now the tens carry fingers have been deployed. We come around here. It's doing its usual rotations. These extra little tens carry fingers come along. They engage in their respective little gears there, and they cause those little paws to rotate over those shafts. They've done their little thing there. Now we've got to cancel this 10 carry, and that's where the problem comes in. Is these guys got to slide back up on their shaft via these fingers, and they kind of jam really badly. And I notice the guy, it's a little less troublesome on this guy to the other side here. There's a solder joint that's been done on this guy, which you can't see it probably at this angle, but he's been brazed or soldered, and some sort of repair job has been done on this guy. And if I can get in there and give it a little help, because right now they're both kind of, I'm not sure who's jamming the worst. You have both these troublesome guys. Here's this guy here. Ironically, there we go. That one moved, but it's more this guy on this side. I guess is the trouble. He does not want to move. There we go. So these guys won't slide on their shafts very well, and it's put a lot of stress on this guy right here, and then a lot of stress on this little cam part there, because this guy down here won't slide back and forth very well. So it's starting to look more and more like I'm just going to have to bite the bullet and take this thing apart a bit. So with a bit of trepidation, I think I'm probably going to wind up taking at least this back section apart. Okay, so I tried taking out these screws, didn't really move. Took off these screws, and then now it's free to come off. So This part isn't a U-shaped casting. I thought it was, so that's something. It does have a number on here, 88, A88 in the casting. I think it's brass. You can see how the holes don't quite line up with the bosses when they machine that. Okay, so there's that part there. Well, for a while there I was theorizing that this was a casting that was somehow floating in there. It doesn't appear to be. This whole thing really is a single casting. With these covers off, they were able to machine plane this surface and then machine plane this surface with some sort of tool that was able to come in here, and then of course they added these side covers. So you have the natural casting release on that side, casting relief on this side, and then you have a machined plane here and a machined plane here, and then they were spot faced the locations for the carry mechanism mount screws. But now, at least with this plate out, I can get at these carry screws here, and so I may take out the troublesome one and see if it'll come out gracefully, and maybe I can divine something from that. But I think it's still further in the other part there, and the problem is all these guys are held in their shafts with pins, so it's looking like you'd have to drive the pins out in order to pull everything apart, which is kind of daunting. In case you're curious, this is the carry mechanism. It's a little machined piece of brass. It looks like it's designed so that you can kind of adjust the angle just a little bit with the one screw, and then it's got this, basically it's a rocking plate that a pin presses on this side to the plate, and then you got this plate here that has some little finger in it that goes in the groove of the little brass barrel that it moves back and forth, and then there's this spring-loaded element here. It acts as kind of a latch, and it has this kind of a wedge shape part to it. It kind of can hook it from one side or the other. So it kind of latches it to one side, and it pops over and latches it kind of the other side there, as I can gauge. And I think this guy is providing most of the spring force, popping it and securing it one way or the other. When it's pushed over and then it is set back. Okay, kind of viewing a little bit more from above. You can see the groove that this guy, little finger, sits in. And this guy then moves back and forth. And he does not want to travel back down very gracefully. Kind of clicks into place. And there may be a referred to a square spring, or so I have to look at the patent, but there's an interesting spring design they're referring to, and it might be something in the shaft that is cause it to go snap in one direction, snap in the other direction. That might be what I'm feeling. It has kind of a little indent to it, but it just does not want to travel on that road. It's moving a little more smoothly now. Okay. There's kind of a snap right there. Well, work on it some more. Well, I took the carry little arm mechanism off of this guy, and I've been hitting it with a lot of cleaners. I tried, interestingly enough, some electrical connector cleaner, and then WD-40, and then silicone blaster cleaner stuff and so forth. And I finally got it to move pretty freely, almost to the point where I almost worrying that I might not have damaged something. I was kind of wondering if maybe there might not be a kind of a latching spring underneath there, and it almost felt like that might be what I was feeling. And so it doesn't latch like it seemed like it might have been before. So I don't know if there really is a latching spring. If you look at one of the earlier patents, it almost looks like there's this kind of a rectangular spring that would latch underneath. But if so, it wouldn't quite make sense doing it that way. So it looks like I finally freed it up. If indeed there's no kind of a latching spring, it took a lot of cycles to finally get it to get to this point where it works this smoothly. And hopefully I haven't damaged anything. I don't think I have. I think I finally freed it up. But it was getting to the point where I was a little worried I was going to have to take it apart. I'll put this carry mechanism back in and see if it works. Well, this carry mechanism installed, it's working a heck of a lot better. I was a little worried that maybe it seemed too freed up. So there's a normal. I have it set for the number 1. It's just easier to look at. Now if I move this guy over past the carry, or the return of the carry point, and it moves so smoothly now. Like I say, at first I thought maybe I'd overdone it, but I think this might actually be normal. How normal it should be, because that is so nice and easy. Moves very smoothly then. So, the number 1, it flicks it over. Of course, it turns over just one increment. Now, if I add the carry, it will do the 1 turn and then an extra turn. There's your extra turn. Your extra turn. That carry, so it does 1. I suppose it might be simpler to eliminate this guy so that the guy next door isn't confusing. One that just returns so easily now. So it does the number 1 and then the carry. Number 1, set it for carry. 1 and a carry. And of course, if I set it for 2, it's going to be. I'll set it for that. 1, 2, carry. I guess. Hopefully, you saw the carry. Okay, so there's 1, 2. No carry. Get past that return point. 1, 2, carry. And it just returns so nice and easy now. It's just amazing. So I guess I will, and it could be also that this is designed to have a little tilt to it to adjust it. Maybe I got it tilted a little bit better. I tried initially putting it in without the further cleaning and loosening attempts, and just seeing if I could loosen it to a state that worked better, and I couldn't find anything that terribly seemed to work any better. It seems to be mostly this piece of brass, this brass part sliding on that steel shaft that seemed to be the problem, and the combination of all the different fluids and lots of working back and forth very vigorously, it seems to have helped. So I think I'll try the guy to the right that's also quite troublesome and see if I can free that one up. So here's the bottom of the machine at the front, and you can see all the bevel gears and of course all of the entry sliders and so forth, and you can see the hand crank there. And what happens here is you have power coming in obviously from the hand crank. I believe there's a little paw and ratchet to make certain you can't turn the crank backwards. It's a bevel gear that then transfers to this bevel gear set, and then this bevel gear set, the first one runs the odometer or turns count mechanism for the lower registers, lower little counting wheel numbers, and then after that you have various bevel gear sets that go to the various number columns. And you can kind of see those guys as you go along until you get to the end here. And then these last two sets, I believe. There's one of them has a bevel gear, and it doesn't have a number set, a number entry, and that just saves a little bit of money, so you can carry over a little bit further. And then you got a guy that's further over yet that doesn't even have a bevel gear, and once again you can carry numbers a little bit further, so you can get a little more use out of the machine without all that extra expense where you're probably not going to enter that data. So the next thing here to do is crank this guy for a bit. And I've gotten to the point where it's running pretty smoothly as long as I got kind of a minimum speed. If I go below a certain minimum speed, the upper register's center little carry mechanisms tend to hang up for a little bit, but I'm like 95% there, to the point where I'm happy enough with it. As long as I don't crank too low speed, and obviously I have to be careful I don't, if it does jam, to ease off on it. So it's kind of one of those, how much speed do you crank versus going too slow versus faster, maybe putting too much force in it. But it's running pretty nice now, and you can kind of see how it carries that stuff in there from this angle. And continuing on our calculator mechanical tour here at this angle, hopefully you can see everything. It's amazing how constrained this mechanism is and still works. It seems like I'm hanging up a little more now. Yeah, I'll just crank a little faster. There we go. Seems to be about the pace it likes. Got up to numbers big enough for that guy, so I guess one did just turn this now. You can see the step drums a little bit between the sliders here. See some of the guys working. And then this guy over here is kind of a interlock safety mechanism to keep you from doing the shift lever that will cause the machine to go between subtraction and addition and so forth, and also I presume keep the reversing mechanism between the two carriages from engaging. You can see the various leaf springs that are keeping things from spinning when the modified Maltese cross isn't engaged on the little restriction barrels. Once again, you can see those step drums, at least somewhat, furthering away. And I think it's just, I literally can't get enough to look at these things. They're so fascinating. And this one is just quite the eye candy because there's so much going on here. And when you got the carriages off, they're quite invisible. And what's nice is this machine has a second carriage, so you can kind of keep things going, even if you would normally not be able to. The carriage being removed, obviously. So, and it's beautiful brass. I love brass. Who doesn't love brass, right? Okay, after much despairing, trying to figure out how to clean these register wheels, various attempts at various cleaning methods. You can see the one with the worst paint loss is probably alcohol. I think I skipped this one. And it's this fellow here. I used simply distilled vinegar. I happened to have a bottle that was, it literally just had a few drops left in it. 5% distilled white vinegar. I don't know. I guess you do cooking with this. Looks like it has food on it. I think there's a stronger version. It's maybe 1% or 2 more that can do, I think it's meant more for cleaning. And of course this doesn't mean I have to go to the store and get some, because literally I just had a few drops left and used that all up. And then as an experiment I then continued cleaning on and used a bit of the diet soda. I more of a thought that it would neutralize the vinegar. I'm not sure if it really helped any. And then I tried a bit of window cleaner, and it might help a tiny little bit. And then most of all, I flooded it a fair amount, at least with a can with a Q-tip, with just tap water, and then work the water out of the opening as best I can with a Q-tip once again to try and get the bulk of that water out and anything else that might be inclined to come out. Just kind of doing this number, and then ultimately I got my little vacuum cleaner shrunk down adapter to a 3/8 piece of hose, and then shot back that water out really good. And then my next step is I'll put probably find this little film of clock or sewing machine oil on this guy, and that little film will hopefully keep the metal from tarnishing quite so much quickly again. And at some point all I'll do is I'll probably clean this out really good again, and I'll go back and paint fill like the number 7 and so forth. I could even maybe just cheat and see if a Sharpie might work. Might give that a try real quick. But that's dramatically better. I was really beginning to think I was going to take these wheels apart, and the problem is everything on this machine is pressed together. So this pin, with this little finger knob here, is pressed into all the gears and cams that are on the backside, and so you have to pull these things apart somehow without damaging anything. And it's a very small looking pin. It looks to be about a 1/16 of an inch shafting, and you can damage things pretty easily. As you can see, this last number wheel, for instance, he's missing his wheel because it was probably broke off. It might have been broke off because you got this kind of awkward little tie bar that swings back and forth, and of course it's just on the end, so it's more vulnerable. Obviously things like my little decimal pointer is bent over. Still gotta figure out how to bend him back without fatiguing and breaking the metal. But that's dramatically better. I'm happy with that, so I'll probably start the production line of cleaning those wheels. It definitely is not the speediest process on earth, but it's considerable improvement. There's some pitting in there that I don't know. This has a lacquer on it, and the lacquer was thinner at some point, and the metal itself started oxidizing and pitting a little bit. That might be what I'm seeing. And then of course the mystery matter down below on these guys is decades of probably people smoking cigarettes, dust, who knows, steam locomotive, coal, smoke, dust. I'm not really sure what this all is. I've never seen wheels quite this darkened before, but it just looks so much better. So yay, another little victory here. Okay, so I think that'll wrap it up for this project here. I got the register wheels about as clean as I can with vinegar. They look a heck of a lot better. Still have a bit of a patina, but what can you say, 110 years old, and vinegar is the best I could figure out to clean those guys. Mechanically it works pretty smoothly now. It could maybe be a little bit better, but you're there 98-95% of the way, and I think it's good enough for the moment. I cleaned it a bit with what is now my favorite cleaning solution, which is sewing machine oil, and it's really cleaned it up, got a lot of the crud off of here, and you can see the engraving better and so forth, and it's preserving the paint a little bit better. Ludwig Spitz and Company maybe could have cut their engraving a little bit deeper. I know they were trying to get away with very small text, and so the engraving's a little on the shallow side. It's interesting that they engraved the turns register, the lower register, but they didn't put any engraving on the little locations for the upper register. Not sure why. Video's getting a bit long, and I'll do another video on how you actually use the thing. And obviously with this extra register, there's quite a few permutations as well how you could use it. The lower part of the machine, obviously, if you can't take into account the fact that the machine doesn't have a traditional keyboard, would still function just like any other mechanical calculator. The upper register, there's all kinds of permutations of how this thing can be reversed in relation to that, shifted to various locations. There's all kinds of interesting possibilities, and maybe the railroad company needed that particular feature. That was the big selling point, obviously, behind this machine. Otherwise, it would have been just a typical Thomas-style arithmometer, which otherwise would have been kind of falling out of favor by the time this guy was made. So yeah, anyhows, I think that's it from the Ed of Ed for this episode. And Thank you for watching.